talked about going over simplifying, which you've been doing for a week now. We just recap what it means to simplify. So some things that we need to be conscious of when we see simplify is that when it says squared, when the square is on the outside of the parentheses, that means that you actually have two of them. And so you either need to FOIL or use the box method to simplify. Okay? After you FOIL or use the box method to simplify, then you need to see if you can identify some type of identity within it. So like on number 1, we identified tan squared theta plus 1. And that was another way of saying secant squared theta. So when we simplify, we got secant squared theta plus 2 tan theta. Okay. On number 2 again, we went over the difference of squares identity. And the difference of squares identity is if I have in both of my binomials, if the terms are the same but the operations are different, then that's a identity. So that means it comes out to be a squared minus b squared. So in this case, my a was secant, my b was tan, and my answer was secant squared theta minus tan squared theta, which was 1. Pythagorean identity.
Oh, yes. All right.
Okay. On 3 through 6, we talked about factoring. On 3, we did factoring. And before we could factor, we identified that this is a difference of squares. So it became a squared minus b squared. And in this problem, our a was sine and our b was cosine. So when we factor, and factor basically means you're expanding it out. So when we factored it, we came down to sine theta minus cosine theta and sine theta plus cosine theta. And now, because I factored it and I expanded it out, if this was the numerator of a fraction and there was something in the denominator that I wanted to eliminate, now I'm able to eliminate because I'm multiplying instead of just adding and subtracting. Okay. On 4, we went over using what we call the CAB method to factor this. We talked about how, remember, ax squared plus bx plus c. But in this case, it was ax squared minus bx plus c. And so our ax squared term is the cosine squared theta. Our bx term is the negative 2x cosine theta. And our c term is 1. And it's the same thing. X equals cosine theta now. So instead of saying x squared or x, we're saying cosine squared theta and cosine theta. Okay, so we did CAB. And CAB is just a way to remember that you're going to multiply the c term times the a term. So my c term was 1. My a term was cosine squared theta. And 1 times cosine squared theta is cosine squared, right? Because 1 times anything is its. Okay? And then our b term was negative 2 cosine theta. So at this point, we need to figure out what are our magical factors. So what factors multiply to give me negative cosine squared, but add to give me negative 2 cosine theta. So a negative times a negative is a, and cosine times cosine is cosine squared, right? So that works with multiplication. Now let's test it on the adding side. So negative cosine plus negative cosine is negative 2. Because when it's a negative plus a negative, it's going to still be a negative. That's like saying you owe me $1. I give you another $1. Now you owe me another $1. So you owe me $2. They don't cut each other. They don't cancel each other out. It keeps increasing your debt. Okay. On 5, we talked about finding a greatest common factor. And so in this problem, our greatest common factor was tan theta, right? So we pulled out tan theta. When you factor something out, it doesn't go away.
When I do that, I look at my notes, and sine and tan is basically the same thing in the basic 8, correct? Because they form one thing, sine of a cosine, right?
No, that has nothing to do with this right now.
I was asking.
No, right now we're just talking about factoring.
So where's the one?
Yes, we're doing the algebra part.
That's
what I'm going over right now, Don. Okay. All right. So tan theta is when you're factoring something out, that means you're dividing it out. So tan divided by tan is. Where does the 1 come from, Don? Oh, okay.
Alright,
So then I have sine theta and tan theta. When I factor this out, all I'm left with is sine. Huh? When you are factoring something out, it doesn't disappear. It moves to the outside of the parentheses. If only Don would let me finish my sentences, I would answer every question he keeps throwing at me. Okay? It moves to the outside of the parentheses. When you're factoring something out, in order for it to remain a true statement, you do not take it away. It moves to the outside of the parentheses. Yes. So this is it in factored form. All right. Wait, I think y'all needed to write 5 down, right? In this class? Y'all needed 5. 5 and 6. Okay. All right, so 5. Do we understand what happened here? Okay, it's the same concept as if I had, it's the same thing if I had, let's say, x plus 2x squared. What's the greatest common factor between that? X, right? So I would, in my head, divide x out, right?
Yes.
I'm not going to delete x. X is now on the outside of my parentheses. Okay? So x divided by x is 1. And then the 2. And then x squared divided by x is x. So this is the factored form of this statement. Okay? And if I took that x away, would these be equivalent statements? No, because this has less x than that one.
How do you know when you can factor? That's all I'm
How do you know when you can factor?
done factor, like working.
How do you know you're done factoring?
Yes, ma'am.
You're done factoring when there's nothing else you can pull apart, nothing else you can use difference of squares with, nothing else you can, greatest common factor, difference of squares, reduce by whether they have a common, well, that's greatest common factor. Yeah, just when there's nothing else they have in common. So when you get to the point where 1 and 2, they're both primes. This is where they stop, right? And this term, does it have an x in it? So there's nothing else I can do. There's nothing else that these two have in common. So I just have to stop. All right, 6. 6 is a little different, and I went ahead and worked it out for you. On 6, what this is telling you is that you actually have, instead of just 1 minus sine to the 4th squared, this is actually 1 minus sine squared theta squared.
Can you do it over, please? Like that, you do it?
Huh?
Can you do it over, like so I can see you doing it?
Do the steps over?
Yeah, mine.
Okay.
If it's not too much to ask.
It's really not.
You know, hit
I
somebody.
got the squares.
I swear.
I was just trying not to get you guys behind.
I just want to see it. So,
I hope you pay attention then.
I am.
All right, so here we go. 1 minus sine to the 4th theta. When I look at this, what it's telling me is that I have 1 minus sine squared theta squared. That means I have 2 of them. Because when you have 2 times 2, that's 4. So I have 1 minus sine squared theta squared. And the reason why we put it in that form is because we can write it as a squared minus b squared. Okay? And so that I can write it as a squared minus b squared. So when I look at it in this form, my a equals 1 and my b equals sine squared theta. So now I know a and I know b, so it's just a matter of me substituting the values in. So I have 1 minus sine squared theta times 1 plus sine squared theta. Okay? Because it's a minus b times
A plus B.
a plus b.
You put it on my note card, I know program on notes.
Okay? So as long as I know what my a and my b is, it's just a matter of plugging into the difference of squares rule.
1 go in 1, 1.
What?
Oh, that's the answer.
What are you talking about?
I thought we was.
No, stop. No, stop.
I don't know when to stop.
Let me finish what I'm doing. You and Don. Pause. Pause. All right, so at this point, I'm good with this one. But this is another difference of squares, isn't it? I have another set of an A and another set of a B. So when I'm looking at this one, what's my A? And what's my B?
Negative sign.
It's not negative sign because you want it to be negative. It's just sine theta. Why? Because identity is a squared minus b squared. So it's already a minus. We want it to be a minus. A negative times a negative makes a positive. So if this was negative, it would look like this.
Why is it not squared anymore?
So, okay.
Why is it not squared anymore? It still is squared. We're just identifying our A and our B to write our factors. Okay? So our A and our B, our A is 1, our B is sine theta. So now I can write it as 1 minus sine theta times 1 plus sine theta. And when I look at this one, this isn't a difference of squares. This is a sum of squares. Because it's a sum of squares, there isn't a rule that exists for this. So this one is going to stay the same. So this is the full factored form of that. So you took this and expanded it out. And now that I'm in factored form, I'm able to eliminate. So if this was the numerator or the denominator of a fraction, I can now eliminate because I've separated my factors. A factor is something that you multiply to get a product. Okay? Like 2 and 3 are the factors of
So would you still do
6.
Would you still do like a form of FOIL with the first sequence?
No, you wouldn't refoil. If you refoil, you're going to end up back here.
No. I know that's what I'm saying. In order to get the answer, you just refoil.
No, this is
No,
the
I know,
factored
no, I'm
form.
saying in order to get 6, what number 6 is, right?
Oh, to check your work? To check your work, you would FOIL and redistribute, and you should come back to that. Is that what you're asking?
Yes.
Oh, okay.
What do you do with the line 1 plus 1 theta?
It stays. Because the rule is difference of squares, and this is sum of squares. So this stays as is.
Okay, since this is not a negative, you leave it.
Since it's not being subtracted, not that it's not a negative, but because you're not subtracting, that's why it's going to stay the same. Okay? All right, so that's difference of squares. There will be a practice problem for you on your classwork, so please give it a shot. On your classwork, you're going to, instead of having 1, I think it's sine to the 4th and cosine to the 4th.
Sine to the 4th, cosine to the 4th, plus sine.
All right, so we've been building up to be able to do proofs. I'm going to try to do proofs as simple as possible. So all I'm going to require you to do is to tell me what identity you're using, which trig identity you're using. Not every math identity. If you were a geometry student the year before last, you learned how to do proofs. If you were a geometry student the year before that, you did not learn how to do proofs. The reason why you did not learn how to do proofs is because it wasn't on tax. But however, my geometry students that took EOC, proofs were on EOC, so you had to learn how to do them. Okay, so you are a little familiar with proofs, hopefully. I hope so. And if you're not, then you'll catch on. All right, so the first thing you know about a proof, about a trigonometric proof, is that the right side you don't touch. This is your goal.
Don't touch right side.
Okay? The right side is your goal. You're trying to make the left side look like the right side. Got it? Okay, that's what you're trying to prove. You're trying to prove that tan x over sine x equals secant x. Got it? All right, so everyone solves proofs differently. For me, when I solve a proof, I get everything in terms of sine and cosine. As you work through the problems, you may come up with your own routine on how to solve a problem. So your steps may be different from another person's steps. There is not one specific way to solve a trig proof. Got it? All right. So what we're going to do is step 1, I'm going to get everything in terms of sine and cosine. Tangent is all I need to change. So when I change tangent, it's going to become sine x over cosine x. And I'm going to leave sine x alone. Okay? The reason why I can make this change is because I use the ratio identity. So over here, I'm going to write my reasoning. My reasoning is ratio identity. And that's why I got to step 1. Okay? Now I'm going to do step 2. With step 2, I'm going to do the math, the algebra behind it, the arithmetic. When you are dividing with fractions, that means you're keeping the numerator, changing the operation, and flipping the denominator. Or if you learn leave, change, change, or if you learn easy as pie, flip and multiply.
What if you learn KC?
Huh?
What if you learn KC?
Keep, flip, change?
I mean KC.
Then you should have understood what I just wrote on the board. I know when people listen to me on YouTube, they probably think I'm rude, but they don't hear you guys. So I'm not rude, YouTube. So I'm going to keep the numerator, which is sine x over cosine x. I'm going to change my operation. I'm going to go from being a division problem to being a multiplication, and I'm going to flip my denominator. Currently, my denominator is sine x over 1. When I flip it, it's going to become
Sine X.
and all I did was do exactly. So now all I'm doing is algebra, right? I'm not doing anything else but algebra. So I can eliminate. Do you agree?
Yes.
Because I have a sign in the numerator and a sign in the denominator. So all I do is eliminate. Okay. So step 3 is the simplified form of this. Step 3, I have 1 over. And what does that equal?
That equals C.
Oh my goodness, we proved it. And what's the reasoning?
Hold on. Reciprocal identity.
Marilla already said it, sitting right across from you.
I didn't even hear it.
I don't think you hear anything. I don't know what you be thinking. And so we prove that this is true by using. That's it.
Can we use all that for tomorrow?
Nope. You got to know the identity. So why would you be able to use your notes? I'm real telling you no.
Hey, who gave it?
That's a fake word that means nothing.
Who gave it?
All right? How do we feel about proofs? All right, we're going to get a little harder.
You want a box?
All right. So on 8, our goal is. That's our goal.
How are we doing this? I go.
Go.
Solid on the right?
Go. All right.
Shut up. I can't listen to you.
Okay. All right. So our goal. That's step 1. We should do what?
Sine over cosine x
Why?
plus, because it's a tangent.
It's sine over cosine X.
But why? What's the rule?
You always ratio identity. It is
Huh?
ratio.
You have to do your
It's ratio identity.
It's a ratio identity. What does cotangent become?
It becomes the exact opposite.
It's called a reciprocal.
Yes, Mike.
I was just saying.
Yep. So my identity here that I use is.
Reciprocal, I mean ratio. Right?
All right. Ratio identity.
That's 1. 2.
Okay. Ratio identity. Tan x is sine x over cosine x. Cotangent x is cosine over sine x. That's all it did. That's your ratio identity. It's on your paper. It's on page, 10 and 11.
Okay. You know how you did the tangent equals sine of x?
Mm-hmm.
Does that tell you what the identity is going to be?
Yes.
First one?
You're telling yourself, what can I do? I can't just make sine x over cosine x without a reasoning. Okay, what's my reason? Ratio identity. Yes, AJ.
So, the point of these problems is to show how we got the answer.
You're proving. When you prove something, you justify with reasoning and examples. Not examples, but explanation. I'm sorry. All right. So that's my ratio identity. Now I'm in this form. Can you combine fractions if they don't have the same denominator? No. So I need to get a common denominator. After 1 comes 2. So I need to get a common denominator. All right. So when I get my common denominator, I'm going to have cross multiply. Sine times sinus. I'm doing chopsticks. So there's my first chopsticks. Okay, so that's my first chopstick. My rice is addition. My other chopstick is, and my bowl is.
It's cotangent.
All right, so all I did there was
Rice in the bowl.
I just chopsticks. All I did was arithmetic.
So,
number
can I
2
come to the next thing? By having cosine and sine at the bottom, you can just cross out the 2, so it'd be.
No, don't say that.
So number 2, you put
That's what I'm
chopsticks.
saying, like, the bottom of the denominator.
All right, so on 3, you don't have. We're just justifying the identities, Don. If you want to write the reasoning here, you can yourself. All right, on step 3, now I'm in a form where I can look for identities. Is there an identity that exists right now?
Yes.
Yes, it is Pythagorean. What is it? 1. Because of Pythagorean identity, sine squared x plus cosine squared x is 1. So my reasoning here is Pythagorean identity. I'm just gonna put. That is not what you said at all. So don't even try
What
it.
I said.
You said because it's a square and cosine there, you can just cross them out. That's what you just said. It's recorded. You want us to rewind it? No? You don't want to hear it?
No.
How did I get this? This? Your identity? Pythagorean? Look on your paper. What's cosine squared plus sine squared?
It's on the first one.
Oh, you equal to 1.
That's why I wrote Pythagorean?
Yeah.
So we just do we just leave it like
No?
You have to make it equal to the other side. Why would you leave it like that?
Exactly. From now on, just ask Alexandra your questions because I think she can be a little more kinder than me. All right, 4. In 4, how can I take this to the next step? Well, what this is telling you is that you have 1 over cosine x times 1 over sine x. What does 1 over cosine become?
I don't even know.
Seek it. What does 1 over sine become? What did we want?
That, seek it.
So, how do we prove that?
It doesn't matter, it's multiplying, just leave it alone.
It's reciprocal identity.
Yeah, what she said.
Marilla. Okay? When you're multiplying, Don, is 2 times 3 different than 3 times 2? No. It's not. Not at all. Okay? So, this got a little, we got 1 additional step added on. But, all it is teaching you to justify your thought process. Okay? That's it. So, we're going to get a little harder.
Wait.
Alright? So, we're going to get a little harder and not be so negative. Alright, so our goal is
1 plus 2 sine theta cosine theta.
I just see an X, but we'll go with it. All right. So this is our goal.
Yep.
We're all understanding the goal?
Yeah, I understand the goal.
All right. So step 1.
Identify which one it is.
Step 1 is a little different here. What does this tell me I have?
You have it 2 times.
I have it 2 times, right? This is saying 1 plus tan x, 1 plus tan x. And all I did there was factor it out, right? Okay? So just so you know what I did, all I did was factor. Well, I expanded my factor. All right, step 2, what would it be?
It'll be 1 plus sine of x times cosine.
Put it in terms of sine and cosine. All right, I have a question. Or more of a suggestion. Before I put it in terms of sine and cosine, would it be easier for me to just FOIL when it's a non-fraction?
What do that, Mom?
Wouldn't it be easier to FOIL when it's not a fraction rather than when it is a fraction? Okay, if you like foiling with fractions, you can go ahead and do it that way. But I'm going to FOIL before I factor. I'm going to FOIL and distribute. When I say FOIL and distribute, remember that means I'm doing 1 times 1 is 1 times tan x is tan x. Plus 1 times tan x is, what's 1 plus 1? So now I have 2 tan x. And then tan x times tan x is tan x squared. Now, isn't that a lot easier to FOIL when it's just non-fraction?
Yep.
Okay, so all I did here was FOIL. Okay, so at step 3, is this all together yet? No, I'm still multiplying, right? So how can I get rid of this outside multiplication? What's the D word?
D word.
I heard it. Distribute. So I'm going to distribute. Okay, so 1 times cosine squared is 2 tan x times cosine squared x is just 2 tan x times cosine squared x. And then tan squared x times cosine squared x is just tan squared x times cosine squared x. And what did we do? All it was distribution. We haven't even did any trig. We just did algebra.
Hard.
We just did algebra 1.
Don't worry. I never done fall before. I never done.
You've never distribute?
Well, I never like did the secret. That's just said.
We do box method.
Bro, what are you even saying, bro?
I don't know. I think he just says things so that he can say that, so that in tutorials or if someone asks him, he's like, I ask questions in class. She just don't be answering them.
No.
Y'all hear his questions though.
I said, what is fall?
FOIL is distributing.
There's a poster right here.
That too.
I don't understand that.
It's exactly what I'm about to tell you. Okay? If you're not comfortable with FOIL, you can always do the box method.
I'd rather do foil.
Box method. 1 tan x, 1 tan x. 1 times 1 is?
1.
1 times tan is? 1 times tan is still tan x. Tan times tan is? Alright, so I have 1. How many tans?
2.
And?
Okay, so.
So you either can box, FOIL, whatever makes your heart happy.
I'm sticking with foil.
I'm talking about.
Alright, so here we go. Step 4 is now, is it more conducive to put everything in terms of sine and cosine? Alright, first term, is this one good to go?
Yes.
Good to go. second term? It's not. So who needs to change? And how can tan change?
Sine over cosine.
All right. Good. Last one. Who needs to change? Why did I square my sine and cosine?
Because tan is squared.
There we go. All right. What made it possible for tan to change into this? Huh? Not reciprocal.
Oh, ratio.
Ratio identity. The ratio identity made it possible for tan to become this.
Oh. I'm thinking about it.
All right. Now what can I do because I'm all in one? I can start doing what? Solving and eliminate. I can start eliminating. So cosine x can go away because I have 2 in the numerator. Notice I only took away the 2. I didn't take away the whole cosine. Okay? Because 2 minus 1 is still 1. All right? And then the last term, cosine squared x, can go completely away because I have 2 in the numerator and 2 in the denominator. So that's eliminated. So in step 5, I'm going to have the simplified form. Cosine squared x plus 2 times sine x times cosine x plus sine x squared. And this is what I'm down to. So I'm getting closer and closer to what I want, right? So my middle looks good, but I need to do something about my outside, right? The middle looks good, but I have to do something about the outside. So how can I is there an identity that can help me combine?
Yes, Pythagorean.
I can use Pythagorean identity, right? Because cosine squared x plus sine squared x is what? 1. So this is 1 plus 2 sine x cosine x. And what do we want? 1 plus 2 sine x times cosine x. And we proved it to be true by what identity? Pythagorean.
Hold on.
Next class, nigga. They go even faster in college, so you know.
Yeah, you learn all this in one semester. Along with a bunch of other stuff. Actually, it's like 2 weeks. And that's 4 classes. 6 classes. Thanks, Don, for not listening to me. I gave you a whole rundown of what today and tomorrow is going to be like.
So what is it?
You better ask somebody. All right, so let's recap this problem. All right, recapping this problem. So step 1 was we expanded, and the reason why we expanded is because it was squared, correct? And so we expanded it so now that we can see all factors of the problem. Step 2, for the people who are not listening to the recap, step 2 is we foiled or either box method, whichever makes your heart happy, to get 1 plus 2 tan x plus tan squared x times cosine squared x. And we got that by either foiling or using the box method. Step 3, we distribute cosine squared x. And when we distribute cosine squared x, we got cosine squared times 1 is cosine squared x, and so on and so forth. Okay? Step 4, we turn everything in terms of sine and cosine. Okay. And once everything was in terms of sine and cosine, I was now able to eliminate, correct? Now I went through and eliminated, and the reason why we went from tan to sine over cosine is by using the ratio identity. Once I eliminated, I came down to cosine squared x plus 2 sine x cosine x plus sine squared x, which means I was closer to my goal. I had the middle term, but I had to do something with the outside terms, right? So with the outside terms, I could use the Pythagorean identity to know that cosine squared x plus sine squared x is 1. So I proved that 1 plus 2 sine x cosine x equals 1 plus 2 sine x times cosine x by using the Pythagorean identity.
Alright.
Okay.
Okay?
Yeah.
So, we went from easy to medium to a little hard, but we made it. Okay? So on your classwork for today and tomorrow, what you're going to be working on is 1 and 2 are simplifying, which is everything we did last week. So 1 and 2, you're just working on what we did, just recapping what we did last week. Okay? So you're simplifying. On 3 and 4, number 3, please look at number 4 on your notes. Number 3, you're going to use the CAB method with the Punnett square. Okay? On 3, you're going to use the CAB method with the Punnett square. On your classwork. On 4, remember your identity a squared minus b squared equals a minus b times a plus b. Remember difference of squares. Okay? You're going to end up doing difference of squares twice. This is similar to number 6 on your notes. Okay? Alright?
Alright.
Now moving on to 5 through 9. Number 5 you should be able to do on the front page. Number 5 is very similar to number 7 that we did. Okay? Number 5 is the easiest one on here. You should be able to do it on the front page. For 7, 8, and 9, I suggest on the back of your paper, you divide it into 4 parts. I suggest you divide it into 4 parts and do 6, 7, 8, and 9. Hey, may I call you back, please? Thank you.
All that work.
So I would do 6, 7, 8, and 9 on the back, just to give myself some room to work with. And you could just write on the back. If you write small, you'll be fine writing in the space provided. Alright, so this is what you're doing today, and this is what you're doing after your quiz tomorrow. Okay, so please study for your quiz tonight.
Any questions?